begin.
Hello, everybody. Yes.
Hello, everybody. Thank you for joining. And we're going to structure this. Jose and I are going to just chat. We don't have slides and decks, but it's more of a conversation. And during the conversation, feel free to put in questions in the chat. And at the end, we'll do a Q&A. But before we start, Jose, do you want to quickly introduce yourself, what you do, why you're interested in this space?
Okay. So I'm Jose Berrio. I'm the Vice President for International Services in Cardio. This is my whole year working with the team. So in the industry, I guess it's close to 30 years already working in instrumentation and monitoring for geotechnical and structural projects. So inside, outside. So yeah, I think my passion for this, part of the industry is huge, and yeah, I'm here just to as Rubik said, to have a conversation, to share experiences, to share points of view, and to have fun also. So,
Awesome. And I'm Ritik. I lead the technology development across the Incardinate Group and its various subsidiaries. And Jose has 20 years of experience in industry. I have about 2 years. So this conversation is going to be experience and guidance along with the other side of technology and change and adaptation. So let's start, Jose. It's going to be a pretty long conversation, but we'll make it exciting for everybody. So let's start today by what are your biggest pain points that you see? And you're a big fan of the observation method. And what we're talking about today is decision intelligence. Decision intelligence at scale from data that's currently fragmented. And even if it integrated in our industry today, it does not give actionable insights because there's so much context, so much domain. And even with the technology today, human judgment is a key enabler of decision intelligence after the data is analyzed to a certain level. So maybe you could talk about a few case studies, some thoughts and experiences on this side of the spectrum.
yes. The technology is key now, and how this observational method has changed in the last 30, 40 years. So, as you said, the problem here is the fragmentation. So the data is not the problem. Of course, we have to follow always the procedure. Without a very good installation, a very good installation procedure, the data is not good. But overall, the data is not the problem. The problem is the fragmentation. So different teams, different activities, different sensors, different assets to be monitored at the same time under the influence of the, let's say, a TBM excavation process. So this is the real challenge now. And, the new technologies that we are applying now, because we are just learning how to apply this new fantastic new world of AI that is helping a lot to understand and to integrate all this information between metro tunnel affected by the TBM excavation building. Let's talk about a big dam, a concrete dam. So how we can integrate all the information coming from different point of views, SCADA, geotechnical, structural. So these new technologies are, let's say, putting this observational method in another position. So I know this method is not applied in all the projects. We used to apply this in major projects, construction and focus in excavation, always big excavation, big tunnels. But the technologies, new methodologies, new ways to communicate the data is something that is changing our world. And the people like me working so many times already in this field are quite afraid because we need to adapt our skills to the new things that are coming, and people like you, young people with young brains, are performing super well. So with new ideas, new tools in our hands. So the future is quite amazing, amazing. And yeah, the data. I think the data overall is good. The instruments or the instrument that we are using in our projects now, quality of the instruments are really good. I'm talking about all the manufacturers in the world. So the data is not the issue. Is how can we convert this data, this information, because it's just information, in in data to make decisions on time. Because this is
Yes.
innovation in our industry. We have the data there, but we need this data on time to take the decisions on time. And these new technologies are helping a lot to talk the same language and to, let's say, to make one team in a construction site instead different teams working in silos. I think this is the big problem. Silos. Information converted to data, to take action has to be in the same time for everybody in a construction site.
So, Jose, this is building up a lot on what we also discussed at Save the Buy-in through our articles, that the first challenge is really fragmentation in terms of the people and the monitoring teams, because at the end of the day, the asset owner, the consultant, the instrumentation monitoring company, and the contractor need to be on the same page. The issue is not really in data collection or integration, it's actually on taking that information and making sense of it to take decisions in either completing the project on time, increasing safety and value of the project, or reducing cost. And the whole biggest takeaway about what you said is that yes, the fundamental rule of observation method does exist. Now we're making it into decision intelligence. And I'd like to take two examples here that really would help the audience also understand why what we do with the information matters a lot more, and the tools we give our clients to make decisions based on the information matter more than anything else in today's world. So let's take an example of this bridge in India. It's the first and only cable stay bridge, and it's one of the highest bridges in India and the Himalayas. High wind speeds, the max wind goes to about 80 kilometers per hour on a very windy day. And we had the job of the end-to-end instrumentation monitoring, surveying software system. So we put our sensors, we put the total stations, everything, and we were getting data from 220 sensors on a cloud platform. But at the end of the day, what did the client want? He wanted to know, or they wanted to know that pre-construction, is the area safe enough for me to construct this mighty mega structure there? During construction, are my design parameters matching? And post construction, what is the life of this bridge? Are any events triggering it, or is anything over time triggering it? So what we did was we ran our satellite technology. We took a baseline of all the environmental and settlement parameters, and we gave a basic, fancier, analyzed report to our client. And what they noticed was instantly, with one go, they asked me a simple question. In that slope near the bridge, where you're seeing settlement historically, is that the location of the small abutment or the big abutment? I said big. He said, you flagged my problem correctly. This is why we ensured the consultant put a monitoring approach of the slope, which was not there before. So actually, through the satellites, we validated one of their concerns that they could not see before by going back in the past and then putting an instrumentation package there. But beyond that, they had various sensors. But to really use the observational method and decision intelligence, let's zoom down to six, which is the accelerometers. And what we did was that we had one on the left side and one on the right side of the bridge. And they were taking data at 200 hertz, 24/7 hours a day, and giving the data in G. And of course, our alarms would trigger, and the chief engineer would say, what's the issue? And why is an alarm triggering? Because when you're looking at amplitude, technically, if there's a heavy train going, the amplitude will increase. If there's a light train going, the amplitude decreases. But the alert limit could be breached but that does not mean the structural health of the bridge is breached. So we started building algorithms, some on top of fast Fourier transforms and power spectral densities, and really looking at the dominant frequencies of the bridge over time and giving them a structural health risk score that now we take the reading once a day, and they know that if any events on the previous day have made any changes or impacted the bridge on its fatigue, the accelerometers give them a very, very valuable insight. So really, we have 220 sensors there, but six sensors for the long-term part of the project can tell them overall if the bridge is doing okay. Of course, there's a huge use of dynamic strain gauges as well to look at the various steel components, tilt meters on the piers, tilt laser displacement sensors to see the movement of the bearings and GNSS. But instead of giving them graphs like every industry player does today, we actually gave them something that made sense to them. And that's the whole concept that how do we move from data to decisions? How do we move from intelligence to enable the human engineers to actually take judgments? Because that is a real role in the industry today. It's not analyzing, processing data, it's looking at that data and taking a decision to impact the community that the infrastructure serves and the delivery of the project. And taking another example, again, we were tasked, and this is in the Middle East. I'm not taking any client names, but this is in the Middle East, and they have this highway in a high risk rockfall zone, and they wanted us to instrument it. And they asked us, how are you going to instrument it? And we were working with a consultant, of course, and the asset owner directly, and a university. So we again took the approach of enabling the client to prioritize with satellites, looked at the INSAR data, looked at the various environmental data, used analytical hierarchy process to process some algorithms, and look at which zones historically had movement. And then we took the ground data as well, the various borehole logs they had and the UAV surveys that we had done with them to really integrate and identify from those 100 kilometers or 50 kilometers, which slopes do we really need to instrument. And then we instrumented those slopes. And now we're integrating that whole data set to really build a dynamic alarm system. So again, the observational method, what is your goal? What is your metric for safety? And then we build a framework for that project to save time, to save money, to add safety and add value. And at the end of the day, give our clients decision intelligence through the data we give them. So yeah, so that's what I wanted to bring out through two examples. And Jose, would you like to share some examples as well on where decision intelligence has really made an impact on the projects that you have served on the other side?
Yes. I think one of the biggest projects in the, in these last years, it was Crossrail project here in London. So I was involved in the project almost 7 years, working for different companies, and here this kind of approach worked perfectly. We had many assets affected by the excavation works, whether the tunnels or the stations, and this integration data everywhere, data coming from different assets, different instruments located in different structures. The big challenge for us, it was to convert, because at the end we are having reports, and the reports are not, it's not having a big report, 30 pages, 40 pages, beautiful data plots, colors, data. And this is not a decision system. So now these new technologies are giving us a big opportunity to convert. You were talking about dynamic sensors, dynamic data. So gathering thousands and thousands of readings every day from 1, 2, 3, 4 sections, plus the other instruments located in this bridge, for example. So the challenge here is to give a bit of sense of and to have an overall view of the asset. So this is something that we couldn't do in the past. For example, in this big project in London. So we tried to keep this kind of let's say common sense, because at the end it's common sense. You are able just to work with a few amount of data. You are not able to work with all the data coming through to the data management platform, and you have to apply. We are humans, so we are not able to work in the same level that AI is doing now. So sometimes this information, it was too much to be able, as a team, as a instrumentation and monitoring team, to take the right decisions. So it was a big challenge. Also, this kind of frame based in the observational method was in place, but it wasn't so, let's say, so good as we can make out now in our real projects. So which is tunnels, now Blue Line in Dubai, you said, this new let's say, challenge we have in our hands with Infinitus, managing 200, 300, 100 structures in the same way. So this is something that will change, as I said before, our world, and we will make us more, more productive and more efficient. I think the work here is efficient. Thinking about budget and program, which is the let's say, safety also, but the main target for instrumentation monitoring is helping the construction team to reduce the project, the program, and save money.
No, I fully agree, and it comes back to a simple concept one of our professors in college taught us of the iron triangle. In a construction project, it's time, money, or budget and value. And how do you optimize this? And then for an aging asset, how do you optimize maintenance? And every single client that we've talked to who's been an asset owner or a consultant has been, as an artist asset owner, it's let me sleep peacefully at night. And as a consultant, they want meaningful data to help their asset owners maintain their projects well. They want the liability of the asset owner to reduce when they're looking at the assets, like on a tailing dam today. We're monitoring a tailing dam in the US, and they had a bunch of piezometers giving data. Of course, LoRa is now one of the biggest buzzwords, but we've developed LoRa. There's so many companies that have developed LoRa, but is it doing enough? It can't get dynamic data. So many issues and noise, so many issues and mess. LoRa is not the solution. The actual solution for them was to really take all of this integrated data into an integrated system. Once we got the data from the various suppliers that they got into an integrated system and set the alert levels with the consultants, my Geotech project manager and the consultant there said that these alerts are very static. On a rainy day, I get an alert from the piezometer. When I'm dredging my pond, I get an alert from the piezometer. I'm really looking at the piezometer to look at the overtopping and the pore pressure changes over time to see if my mine closure is happening on time. As an owner, the only thing I care about is mine closure and safety of the communities around me when I'm monitoring. I don't really care about anything else. So we sat with him, we just looked at the metrics, and this was pretty long process, but eventually what we learned was after doing a lot of machine learning algorithms on the historical data that there was for 3, 4 years, that the piezometer data actually depended on the seasonability, on the pond level, and on the dredging. And the piezometer is installed on 3 levels, and the actual impact that we had to monitor was on the top level of the piezometers. So we simplified the amount of data needed and actually build them a daily metric based on life site conditions to take decisions. Now, to do that is possible today. To do that at an individual project level is possible today, and to do that at scale is possible today. Because we did it with 9 piezometers at a mine, and we did it with on the bridge that I was talking about earlier, we took 150,000 data points per month, and we took 4 months of data. So around 450,000 data points, a couple of terabytes of data into our data infrastructure, and we actually built special algorithms to give the client decision intelligence. So you can do it on small projects and you can do it on large projects to really answer the client's needs, which could range because today, I mean, you use ChatGPT all the time, Jose, or Claude. Claude helps you take decisions based on the data you feed it, but it does not have the domain that you have as a human or we have as an industry. It doesn't have the data. So, how do we take that same framework and build intelligence that is unique to our industry at scale is really the benefit. So we've given examples of a London project, of a landside project, of a bridge project, of a mine. And you can see across applications, the same philosophy has been working really well. So yeah, so Jose, how do you feel like as because you've also been a project manager, right? Like, and you've coordinated between construction teams and consultants. What do you not like doing as a project manager, and what do you like doing as a project manager on the job? And what is the real value for you?
Oh, at the end, the project manager, I think the main task for a project manager is people, is just to organize people and to, also, the is to deliver the project. Also, this is the main target, but your 90% of the time is you are just managing people and taking decisions. And this is related with this kind of decisions in our field, in our industry, is related to instrumentation and monitoring data information, because this is our deliverable, sorry, data. We have to deliver data, good data, in the best way that we can do it. So the most challenging part in project management is also the challenging part, and I think the best part of our work, which is is people, is the team, is the relationships. But also we have to deliver our product, which is data. And this data, I didn't mention, we had a very important project in Saudi, neon tunnels, in terms of this data that we should deliver. We were managing almost 15, 17 tunnel phases at the same time. So the data from these different activities of the same project should be in time and in place very, very precisely also. And these new technologies help us to comply with the requirements of the client. Sometimes the requirements of the client are quite challenging. And as a project manager, in this case, the project manager was a colleague from Saudi team. This kind of organization, this kind of skills to manage to get everything on time and the daily meeting ready to take decisions, it was something that makes you to continue and 17 tunnel phases, 15 tunnel phases every day in the SRE meetings, ready to for the client is something that moves you, every day. So yeah, so
Yeah, and I also believe that 17 tunnel phases, when we were doing that project, of course, we had our survey teams and installation and monitoring teams on the job, but we also had our own software, our own data log with our own sensors, but we also had our various partners providing us with data sources like the total stations, like the laser scanners. And the ecosystem went beyond just monitoring into geospatial and remote sensing. And now, when you're looking at that dynamic level of data, the challenge there also was to really explain it to the asset owner. And the biggest time that was spent was really going to the debrief meeting, taking those 300 pages of printouts out in a normal project, not Neon, but in a normal project, and then seeing which graph had an issue. Instead, if you could really tell you where to look, that's the problem that we have been able to solve actually at scale. And for all our partners on the call, thank you for bringing the best technology to us as a monitoring company, and even to our clients who buy a lot of products from us on this call or even competition. The real goal as an industry, as we mature from a fragmented, siloed industry giving fragmented solutions, is how can we go to the end customer and really give them a framework to solve their needs and take decisions? Because even as a monitoring company, when we go to a client, at the end of the day, we're solving a need that is beyond the technology that we're offering. The need before this technology came was solved by manual readout units, was solved by Microsoft Excel, was solved by paper, was solved by pen. Today we have software, today we have machine learning, today we have deep learning, today we have cloud. What this has really done has enabled us to take the best ingredients in the market and build a solution like Infinitus that can enable us to do it more efficiently and at scale. So taking those project examples is what really drives the client's metrics that need to be monitored and how we can make their lives easier. And I'll give another example of how we made their life easier. So we were monitoring this another metro line. So in cardio, as a fun fact, is that about one third of the metros in the world outside China have been fully monitored by cardio. And in one of these one third metros projects, we were doing a deep excavation of a station. And there we saw the piezometer data giving anomalies. And we saw the inclinometer data giving anomalies. And we had about four consultants on that job, or three consultants, I don't remember now. And they used to call us for a meeting at the end of the day and they said, check your readings, check your readings, check the sensors. And we checked the sensor, then there was nothing wrong with the sensor, nothing wrong with the IoT, nothing wrong with the data. So then the consultants started studying that data, and what they realized was that when they were grouting the concrete in, there was actually too much force going in, which was making the D-wall move more. And the design was the actual issue in the amount of concrete that was being poured. So from just piezometers, inclinometers, and we validated with adding some total station and manual survey, we really helped them reduce the amount of cement used on that project because they agreed, the consultants and asset owners, with the monitoring data from two types of sensors that there was an issue with the grouting. Now, win-win, because when you're reducing the amount of cement used, you save cost, you save time, you have a much more flexible design. But the biggest one is environmental. Look at the amount of cement that you've saved on the project. And people don't see that side, right? So, but when you execute projects and build the technology, that gives the client a big advantage that they don't see from the monitoring side initially because it has been a compliance. But through case studies, through examples, we've really been able to build this framework of Infinitus to move people from compliance to integration to intelligence and now to governance. Building frameworks for asset owners and governments to manage assets at a national scale or at a portfolio scale, where these insights of environmental sustainability, safety, time of completion, maintenance optimization become the priority over how are we monitoring, what are we monitoring, where are we monitoring through the technologies. So, Jose, what are your thoughts on what I just said? Anything that's
Yeah, agree.
resonated? Anything you don't agree with?
No, 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 no. Totally agree. So, and this is our daily basis. So, every project is giving us this final, this final point. So, monitoring, geotechnical structural monitoring is always helping to improve the design and the construction. And when the construction is the activity to be monitored. And in terms of maintenance, we are now dreaming because it was impossible for us to monitor 200 kilometers of motorway in Costa Rica, for example, and we are now able to do that with the same approach. So we will optimize the resources for the client in the maintenance process that they have. So we will avoid with time the landslides, the differential settlement embankments, water issues. So this is now our real world with new tools, but same approach. Our approach is the same, always being behind one side of the client, helping them to improve in safety, time, and budget the projects also. So, totally.
I think building on that, like today also, when we talk to a lot of the asset owners and even the monitoring companies, they talk about cost and they say, yes,
Yeah, yeah,
the cost of your data log is so much and it cost me one fourth the price to send engineers on site. And then when we talk to the engineers, and we have around 300 installation engineers in cardio with surveyors. So we feel the same thing. But we're building this technology to enable those 300 engineers to make better decisions for the asset owner. So how do we do that at scale? How do we reduce the time of reporting? How do we reduce the time of analysis to enable engineers to help in engineering decisions?
yeah. So we had this conversation yesterday about cost and value. So at the
Yeah.
beginning, we need to demonstrate that we have a very competitive. Always the price is on the table till the client really understand the value of our proposition. So once the client understand what we are, adding to the activity, they understand that the cost is ridiculous. So the most important thing here is value. What can we do for the client? What can we, help to reduce the uncertainties? Because here we are talking about uncertainties. So the monitoring will reduce this kind of risk in terms of management, construction, whatever. So the always the cost is something important, but the value is what we are, always
Mhm.
uh, pursuing is the value.
And And another thing about monitoring when we're going to decision intelligence is also redundancy, right? Like today we look at the same parameter in different ways when we're monitoring. So, like for example, at the ones that we tower, we had two ways to measure depth, two ways to measure settlement. Because in the criticality of the project, you have to have redundancy. And we had Dr. Joel on this podcast about 2 years ago, and right now he's partnering with us to monitor the tallest tower in the world, the Jeddah Tower. And his whole framework is also on the Jeddah Tower with the Encardio team to really look at redundancy. So we have inclinometers, we have total stations, we have levelers, and we have a GNSS network to monitor the verticality of the going to be tallest tower in the world. 4 to 5 technologies converging to give that accuracy. No one technology. We could have easily done it with one. But to give that redundancy, to give that engineering judgment, we have to validate. And it's the same approach that you take with doctors, right? Like today, I will get my temperature checked. But if there's anything, I will always take more tests and then go to a domain expert in the field where I need a treatment to get that treatment. Which is why with Infinitus, what we're really doing is we're giving a standard blood test report with all the necessary parameters to the asset and then working with that domain expert to help the asset owner or the government agency or the consultant solve the problem. So that the gap that's really been unlocked is that we're really coming to that point where we can help them solve problems by making sense of the data and not just providing the data in raw format or in a formula-based format. And when we go from raw to formulas to integration to now convergence, that is the flip point. And if you had one takeaway from this is that really the convergence to intelligence framework is possible today. And the more domain, the more experience that you as engineers have, and when you use the process of Infinitus, which starts with data collection from Earth to sky, we collect data from satellites, from various sensors, from total stations, from drones, from mobile mapping. We integrate all this data into one place on both the hardware and software level. We do processing, we do an analysis that are specific to that application or domain. Then we build early warning systems, and then we give the data in a format for the human engineers to make judgments based on the decision intelligence provided. So that is the whole workflow. And Jose, before we open it up to the audience for questions, anything to add?
Yeah, as you say, you are saying now, and we said before in the beginning of this conversation. So the clue is to convert this kind of fancy report that we are doing every day, 100 pages. We need to convert this in a real tool for to take decisions, and this is the way that you are explaining now how Procure, how Infinitus are making this, you know, making this information interesting to take decisions on time. So this is the clue. This is the clue. No, the raw data or the amount of raw data is not the important thing. Also, it's important, no? But the important thing here is how we are able to transmit the information as a real tool for the client to take decisions. Right? This is the clue.
So, as we conclude today, the real challenge for the industry is how do we take this large amount of data, which is now not the problem. The integration is not the problem, but how do we take this large amount of data and make it ready for intelligence, for engineers, asset owners, consultants to come into one unified conclusion to take decisions on their most critical assets via solutions like Infinitus provided by Encardio. So thank you all for coming. We will open the Q&A so you can put your questions on the chat or using the Q&A button, and Jose and I will be happy to answer them. And the podcast conversation that we had will also be available on YouTube. If and feel free to also reach out to us if you have any questions after the call on anything we've spoken about today. So thank you. Any questions, anybody? Uh, yes. Let me unmute. Allow mic. You'll have to unmute and ask the question.
So then, I'm Amod Gujral. Then, what is your approach on monitoring of bridges using Infinitus? You
So for bridges, specifically, what we gave the example of one of the bridges that we're monitoring in India. Now we're scaling this approach globally, where we're again starting with an environmental and inside satellite monitoring approach to look at how historically the bridge and surrounding areas have been impacted. And then we're using accelerometers and converting the raw data from the accelerometers using fast Fourier transforms and power spectral densities to give a damage index of that bridge. And the unique thing here is that we've reduced the 24/7 monitoring data requirements into one reading per day. And but the data is still taken dynamically and processed on the edge and sent to the cloud. So the accelerometers really tell you the overall the overall health of the bridge, because we're looking at how the frequency is changing over time for each span and across the bridge. So if there's any change in the FFT or the fast or the frequency or the three major modes, that means there's some issue on that span or some issue on the bridge, so we need to inspect it or instrument it more. Then for the steel components, we're also using dynamic strain gauges, again with a lot of processing on the edge. And for railway bridges specifically, what we're doing is that when a train comes, we're taking one train with a similar load again once a day. and we're calculating the envelope of the peak strain and peak stress. And based on that, what we've really noticed is that for each and every steel component, if we've had a lot of similar data, and we've again got a weighted index to really see the health of that steel component, and then we're using GNSS to see the movement of the bridge, and we can theoretically calculate based on where the GNSS is installed and the span and the span length, along with thermal corrections based on seasonability, what the theoretical movement should be. And if the actual movement is more than expected, then there could be some issue with the bearing that we can go and further monitor. And for bearings, we're using laser displacement sensors to see the movement of the bearings and tilt meters for the piers. And if it's on a riverbed, of course, cause a issue. So to summarize, we're really using 6 fundamental sensors to give an overall health score of a bridge. And as issues get flagged or as we monitor these bridges over time, we can always increase the various parameters if needed, depending on the health.
So then, by the same token, what would you use for an airport, and then for a, say, a landslide area? These two
So,
parameters, your approach, how infinite is, would take care of the so landslides and say airport.
so landslides, we gave an example earlier of the roadway in the Middle East with rockfall, but we can give another example of this project we're doing in India, where again, we used about 10 years of historical satellite data, both INSAR and environmental from various sources, along with uh, DEMs, which are basically terrain models of the ground that we get from satellites again, to map mass areas and really look at where there has been historical movement or where there could be movement. And we use various machine learning techniques to predict critical areas. Then in the critical areas, we look through surveying with UAVs and drones and LiDAR. We take a couple of readings once every month or 2 months in semi-critical zones. So with the satellites, we rank it into 3 ways: critical, investigate, and clean, which is clear, so traffic light approach. In the clean areas, we just periodically keep monitoring through satellites to see if something new comes up. In the investigate, we take basic surveying over time and install critical sensors such as piezometers, extensometers, and in-place inclinometers. And then in extremely critical areas where we've seen risk, there we instrument even more heavily, where we can include more sensors. And also we work with the consultants then to look at rockfall mitigation or landslide mitigation area to technology such as meshes, etc. And for airports, we use a very similar approach where we use remote sensing technologies to prioritize. And then we use very specific sensors to look at the pulse of that structure and then deep dive if needed. So the same approach can be used across any asset type based on the customer's need for long-term asset monitoring. Jose, anything to add on this?
Yes, and not just for these 3 different applications, so bridges, airports, and landslides. We are now exploring also the way to apply finiteness in tiny dams and concrete dams. So this is something that I guess we can expand. Of course, we have to, adapt the infinitus approach to all the assets, all the structures. But infinitus is something that will change the way that the monitoring, the geotechnical structural monitoring is now approaching to this kind of solution. So is the perfect tool to gather information and to convert this information in real data able to be in place in client's decision. So
Awesome. Anything to add to that?
So that means even in case of tunnels, the same approach can be used.
yeah, of course. And just imagine TBM tunnels. Now we are working in Brazil tunnels for TBMs, for Hermex, and we are combining the ground and the structural instrumentation, the tunnel alignment with the TBM operational parameters. So this information is already gathered, and Infinitus here is the perfect application for Infinitus to combine different information from different, let's say, monitoring applications to gather to make just one platform and this intelligent data able to help the client to take decisions on time. So panels is the perfect environment for Infinitus is also.
Perfect. So thank you for the question. And we have some on the chat talking about basically AI and satellite data. So we process our own satellite data here and do analysis, and we really use it as a tool to prioritize. And once we have the prioritization, we then integrate that with ground instrumentation to with specific algorithms, especially like GNSS and INSAR show a lot of correlation on some sites to improve to really improve the accuracy of the satellite data. For example, in a project in Dubai, we got the INSAR accuracy to about plus minus 3 to 6 mm with ground control points. And about conflicting data that Pankaj has asked, there's never really conflicting data. All data has a meaning on a project. Of course, if there's noisy data, we can eliminate it. But the data always has a reason to be there. And using the observational method, we take analysis with the consultants. And when we talk about AI in general, because a lot of people are asking about AI, it's AI is not the real answer to the problem that Jose and I are talking about. It's really bringing the people into the same room and giving them a way to understand the data that's relevant to the application. And a lot of this analysis is actually currently being done using even statistical models. So the use of ML and AI is to, yes, of course, make all this dynamic data a lot more consistent with the needs of the client to reduce the cognitive load that a human needs to understand, because machine learning algorithms can look at a lot more data than a human can in a single day or hour or even minute. So where you're really using machine learning to process the data rapidly as per the need. And we're taking this data to enable humans to make decisions through the dashboards and the tools. So it's not really about AI and ML. It's really about taking the data based on the customer's needs, building a way to help them take better decisions. AI and ML are just technologies today that help us do it very, very quickly because of the data processing capabilities through deep learning, through machine learning, through statistics. So on that note, Jose, anything to add?
Yes, you're right. 100% agree with you. We have to keep the fundamentals. AI is coming here to help us how to manage the data, how to improve, this kind of decisions based in data. But the fundamentals always are there. So we are talking about manual to automatic, 12, 13 years ago, this new technology changed our world as well from wire to wireless, which is the LoRa technology, but also the fundamentals has to be there with us. So the AI will help us, but nothing else.
Yeah. So to summarize what Jose and I said, AI will be used to process data at scale and understand the context of the data at scale, to give the humans a way to take better judgments and faster judgments proactively instead of reactively on critical infrastructure projects. And with that note, we will close today. And thank you so much, everyone, for attending. And we hope that we gave several examples on why looking at monitoring projects from the real need of the asset owner and consultant, depending on the project type, application area, matters more to add value. The value could be environmental sustainability, it could be safety, it could be cost, it could be time. And really building solutions that integrate vertically to solve their needs through end-to-end services. And that is what Infinitus is for our industry. So thank you.
Thank you so much, everybody, for your time today.
Thank you. Thank you.